Hi guys, welcome back to another tutorial about network troubleshooting. I hope you have enjoyed the previous tutorial about the ping tool, and today I'll expand your knowledge further and I'll talk about Nslookup. Nslookup. Right, so this is a network tool available in the command line in Unix and Windows systems, and is used to query DNS records for a given domain name or IP address. In case you're not aware of what DNS is, allow me to digress a little and let me mention that DNS stands for Domain Name Server, and this is virtually a large phone book for the internet. And DNS maintains a directory of domain names and translates them to IP addresses. And to put this into perspective, whenever you're accessing a website or sending email, your computer uses a DNS server to look up the domain name you're trying to access. And this process is called Dns Name Resolution, and you say that the DNS server resolves the domain name to the IP address. For example, when you enter www.google.com in your browser, part of the network connection includes resolving the domain name google.com into an IP address, and that should stand for the Google web servers. Right, so let's return to Nslookup. Right, this command will fetch the DNS records for a given domain name. So for example, if I run Nslookup google.com, it will fetch the domain records for google.com. Please do remember that IP addresses and domain names are stored in DNS servers, and this command allows you to query these servers to gather info about a specific domain name. So let's say we want to see the IP address of google.com. For that, we can simply press enter here and see the output. Right, so as you can see in the standard output, the first two lines show you details about your DNS server. And as you can see here in my first line, my DNS server happens to reside on my router because my router has this IP address here. So the query answer that we received from the server is this one: the name of the server and then the IP address. And the IP address in this case is called an A record, and this is a DNS record type that simply maps the domain name google.com to its IP address. Right, so let's see other types of records. For example, if we want to see mail exchange records, we can simply type in Nslookup, but I will use an option, and that option is -query equals mx for mail exchange and for google.com. Let's press enter and let's see what the output tells us. Right, so in case you're not aware of mail exchange, these are DNS records that map a domain name to a list of mail exchange servers for that domain. So this MX record tells that all mail sent to @google.com, right, should be routed to the mail server in that domain. So in this example here, we have under the Non-authoritative Answer section, we have 5 MX records for the domain google.com, and the integer given here gives you the preference of that mail server, and the lower the number, the higher the preference. So in this case, this has the highest preference. Right, so you may have seen keywords such as authoritative answer and non-authoritative answer in the output. An authoritative answer, there's none here. Let's see above. No, we have just non-authoritative so far. But anyway, an Non-authoritative answer is any answer that comes from the DNS server which has a complete zone file information available for the domain you ask. And there are cases when DNS servers do not have available this zone file information for a given domain, and instead they maintain a cache file which has the results of all the queries performed in the past for which they have successfully returned an authoritative response. And when a DNS query is given, it searches this cache file first and returns the information available as a non-authoritative answer. That's why we got these headings here, because they were taken from the cached file. Right, so allow me to show you another type of record, and that's NS or name server. And in that case we can simply type in Nslookup query equals ns from name server for google.com, and as you can see here in the standard output, the query has returned as a non-authoritative answer all the name servers associated with google.com. Right, so a name server is a record that maps a domain name to a list of DNS servers, but pay attention, authoritative DNS servers for that domain. So this will output all the name servers associated with google.com. Right, so another interesting thing to see would be start of authority or SOA. So you can type in that by typing, in this case you will use the type option equals SOA. Right, so this is the standard output. So the SOA record provides the authoritative information about the domain, about any email addresses associated with the domain admin, domain serial number, and so on. So when you run the command, you'll see info like this. You have an origin, and this origin comes from name server 4, and then you have a mail address, and this is the mail address of the domain admin. In our case is dnsadmin google.com. Then you have a serial, and this is some sort of revision numbering system that DNS servers use. Afterwards you have a refresh, and this is the time in seconds when the secondary DNS will poll the primary to see if the serial number has been increased, and if so, the secondary DNS will make a new request to copy the new zone file from the primary. Right, then you have a retry, and this specifies the interval to reconnect with the primary, in this case 900 seconds. Then you have the expire, and this is the time in seconds that the secondary DNS will keep the cache zone file as valid, again 1800 seconds. And then you have a minimum, and this specifies the time, so 60 seconds, that the secondary DNS should cache the zone file. Right, so if you'd like to see all the above information in one place, you can simply type in Nslookup query equals any for google.com, press enter, and you'll see all the above output in one single place. Right, so that's all for this video. I hope you have enjoyed it. Don't forget to subscribe, and I'll see you in the next tutorial.